Understood? It will not understand the cost matrix. What it will understand? It will understand bandwidth, delay, load, reliability in MTU.
Okay.
That is the reason I am giving the what I am doing over here. I am advertising OSPF inside Eigrp with the metric value of Eigrp, because Eigrp only understands what? It only understands the K values. Understood?
Okay.
Okay. So I'll share this file with you people after the lecture. Now the next thing that we need to study we have stopped at the distribution list, correct? We have stopped at distribution list. Now we have to study more about something, the route filtering methods. So we have done the distribution list. We have done passive interface, prefix list. Now prefix list, what is prefix list does? What does prefix list does? See, prefix list is used as an access list only. It is a type of access list only, you can say. Okay, it is a type of access list. The iOS IP prefix list, another tool for matching the routes. This is something, another tool to match the routes. Okay. Just give me a second. So prefix, as what I was telling, prefix list is another tool for matching the routes. It is another tool for matching the routes. Okay, so it matches two components of an IP route. The route prefix, that is the subnet mask, and the prefix length. Okay, so see, a distribute list is used to control routing updates either coming to or your router or leaving from your router. Okay, so distribute list work on a variety of different iOS routing protocols. One of the easiest way is using access list, what we have seen. Now prefix list, it matches two components, as I told you, the route prefix and the prefix length. The route prefix is the subnet number and the prefix length is what is the subnet mask. Now the command that sets either a deny or permit action for each matched prefix or length. Like if I give you some examples over here, you can have a prefix list in such a way. You can set that I want to deny or permit the networks having the slash value as 8, having a slash value as 8. So this is something a mask as 8, subnet mask as 8. Or what you can do, you can say I want to deny the network with slash value 8 that is greater than, I want to deny this network that is this network, any network that is having slash value greater than 9. Now greater than 9 means 9 to 32, between 9 to 32, if anyone is coming with this network, okay, other than this slash 8, it will deny it. So this thing is not possible with access control list. Okay, like this also. I want to deny the network greater than 24, less than 24. That is equal to 24, you can say. 24. Okay. So here you can see 10 dot network less than equal to 28. Less than equal to 28 means 0 to 28. We have not given any greater than sign, or we have not given any. See here it will automatically take greater than means till where you can go, you can go till 32, from 9 to 32. Understood? Here you are giving whatever is less than 28. Either you can allow them or either you can deny them. Means 29, 30 and 31 will be allowed for here in this statement if you are giving deny for this statement. Now you can do it for default route also. This is for default route. Okay, match default route. Match default route with the subnet mask as 0. And for all the routes, match any route. To match the any route, you can give this thing. Okay, so let us see it practically how to configure prefix list. Then it will be more clear. Same topology. I'll use R1, R2 and R3. Okay, show IP protocol. There is no protocol running, so I'll be running RIP. Okay, let me show you for RIP. Router RIP version 2. No auto summary. Then I can advertise the network. Network. I can say 0.0.0.0. Okay. For all the networks, if I say do show history, all the routers will be having the same commands. I'll say paste the command over here just. no auto summary network. Okay. Now if I want to verify the things, what I need to do, show IP route rip. I'm getting rip routes over here. See all the routes. I'm getting 13.30.12.20.3. And 2 networks on my R1. If I go on R2, show IP route rip, I'm getting all the individual routes. Okay, understood. If I go on R3, show IP route, I'm getting all the routes over here as well. Now I need to configure the same thing that we have done yesterday. Configure R3 to deny 4 of the loopbacks, that is 13 network. Okay, R3 should not send the 13 network from being advertised to R2. Okay, to match the network, here we will be using prefix list. Prefix list. What we will be using? Prefix list. Now to configure prefix list, the same IP prefix list we have to give, and here it will be named. So I'll say CCNP is the name. Then after that, deny what? I want to deny the complete 13 network. So 13 network slash 24. 1 network slash 24. All the loopbacks. 2 network and 3 network. Now, as we used to give the permit statement, here we have to give the permit statement as we have to give the permit statement also over here. Okay. So what will be the permit statement over here? IP prefix list CCNP. I will say permit all the others. For all the others, I will say any subnet, any network with any subnet mask that is less than equal to 32. Less than equal to 32 means what I'm saying over here, any subnet mask, any network with any subnet mask which is less than equal to 32, excluding these network, allow them. What we used to give in access list, allow any, okay, permit any network with any subnet mask. So here we will give it in this way. If I want to verify the prefix list, show IP prefix list, this is the sequence numbers you can see over here. Okay, this is the sequence number 5, 10, 20, 25, okay, 15. These are the sequence number. Now, if I want to check it on R2, previously I was getting all the routes from 13 network, show IP route, clear IP route star. Let it get converged. See, 13 network is been removed. Still 30 network should come over here. It will come. Why my 13 network is coming? Okay, I have not given the command for, I have not executed the command inside RIP. I have not executed the command. So I need to execute in which direction. So distribute list I am using now. Previously I was using access list. Now I will be using prefix list named as CCNP, and going outside the interface serial 3/1. Out the interface serial 3/1. Again go on R2, clear IP route star. Now I will not get the 13 network over here. Any of the loopbacks, I will not get any of the loopbacks of 13 .
Can you go on R3? I just want to see the last command which you entered. Okay, 13 is blocked.
Distribute list. I'm using distribute list with prefix list. Here the change is I'm using prefix list. That's it.
Okay. Okay.
Okay. Now if I go on R2, you can see I'm not getting the 13 dot loopbacks. I'm not getting the 13 dot loopbacks over here. Understood?
Yeah.
Okay. Now, if I suppose go and add some more loopbacks over here, interface loopback, suppose for IP address, suppose I give 13.0.
But this can be done through access control list, right? In a ACL, we can define deny for all 13 network, and then just permit any.
Okay. So what is the use of prefix list is if suppose I want to deny other networks also that are not having the subnet mask of less than 32. Suppose I want to deny, that's what I've shown you over here. What I did, I only want to permit that are greater than equal to 24. If I only want to permit the /24, see this is my network, 10 dot network, and I'm saying that permit or deny specific network, permit or deny specific network that is starting with 10 dot and the slash value is 8 greater than or greater than equal to 24 or less than equal to 24. Whatever is greater than equal to 24 and whatever is less than equal to 24 means it is equal to 24. So I want to either permit or deny. This is not there in access list. You cannot do this thing with access list.
So in this command, this will like permit everything except 24, right? /24.
Yes.
And if I put deny, then it will deny everything except
Except
/24.
24. This thing you cannot do with the access list thing.
Okay.
A slash value you cannot make it changed in the access list. This is the difference between, there is a very small difference between access list and a prefix list. This is a difference. Okay. So what I was doing, I was giving the IP address. Okay. Interface loopback 5, 5.1, interface loopback 6, 6.1. Okay. Show IP prefix list. So here is my prefix list. Okay. Now I want to configure R3 to deny the 13.4. network and 13.5. network also to advertise it to the R3 R2's routing table. Okay, so first I will see whether I am getting the loopbacks that I've configured. Again, I have given the statement, that is why it is. See, I am getting 456. I am getting 456 over here. Okay. Now I want to deny 4 and 5 also with the help of prefix list. So what I will say, IP prefix list CCNP. I want to deny. Deny what? Deny 13.0.4. network /24 and 5.network/24. Show IP prefix list. Now just let me know, will this work?
No, this will not work.
So by default, prefix list adds the new statement in the last with default sequence order, correct? So
first of all, this will not work because permit
yes,
less than 32, it will permit everything, right?
That's what I told you. That's what I'm telling. That it will add it on the last as the access list does. As the access list does, it will add it in the last. So, but in the access list, in the named access list, also you have some options. Okay, so here also in the prefix list, we have some options. So what I will do, I'll remove these statements, whatever I have given. So even we can add statements in between by using respective sequence numbers as per the requirement. Now, as I told you, we are having the sequence number over here. Okay, so if I want to add in between 20 to 20 and 25, what I can do it in this way: IP prefix list CCNP. Then see, you are having a option of sequence number SEQ, sequence number. Okay, so what I will do, I'll use this sequence number and I'll give any sequence number between 20 25. So I will give 21 and I'll say deny 13.0.4.network/24. And for 5.network, I'll use sequence number as 22.
This is same in ACL, right? Similar way.
Same like ACL, the sequence number. As it is named, so we can just do things in this way. Okay, understood? Now if I go over here and if I clear the IP route table and if I check, I will not get those two networks as well. See, I'm only getting 13.6.network. I'm only getting 13.6.network over here. Understood? Okay. I can do it for summary routes also. So what I'll do, I'll just remove the prefix list, whatever I've configured. So I'll say no IP prefix list, and also I'll remove the whatever the distribute list also I'll remove. Okay, I've removed the distribute list. Now I'll configure R3 to deny 13.network, the complete 13.network. Okay, from R2, and I'll use prefix list and use summarized address. Okay, summarized address this time. So I'll configure how I need to configure it on R3, or this time we can do it on R2. So IP prefix list, suppose CCIE over here, I'll take deny. If I make the summary address out of it, I'll get /22. I'll get /22. Okay. And the permit statement prefix list CCIE permit any network with any subnet mask less than equal to 32. Then router rep distribute list prefix CCIE, whatever is coming inside serial 3/1. Correct? Clear IP route star. So what do you think? Will it work? Is it working? Is it working? Whatever we want, is it working over here? No, it is not. We don't want the complete 13 dot network, but still we are having the 13 dot network over here. What is the problem? No routes get filtered.
Can you show history? I want to see what's the command.
Sorry.
Show history. What command you configured?
What command I gave?
Yeah.
Do show history. Why it is not working?
In serial 3.1 distribute, you haven't defined in or out, right?
I have defined over here whatever is coming in serial 3/2.
First of all, 13 is not on R2, right? It's on R3.
That's what I told, that I can do it on R2 as well. How I can do it on R2? I can specify that whatever is coming inside the R2's interface, just remove that thing. Just remove those networks, whatever is present in the prefix list. I have shown you this thing yesterday also.
Then it should be applied on serial 3.0, right? Because from serial 3.1, the 13 routes is coming, right? /22 routes are coming.
See, if I am doing on R2, what I will say,
that's R3, right?
Yeah, this is R3. If I am doing on R3, what I'll say, if anything is going out of this network, out of this interface, just check this prefix list. Correct?
But here it's on R2.
Sorry?
I mean, you are looking on R2, router 2, and
yes.
explaining
So
what
if
R2.
I am doing on R2, what I will say, if on this interface, if anything is coming inside, and check the prefix list. So that's what I've given over here.
Okay.
That's the thing I've given over here.
I13. Okay.
Getting me?
So it's not denying, right?
It is not denying. Why? See, I told you prefix list is working with the slash value, is based on slash value. And there is no /22 route present.
Yeah.
So what we need to do, we need to configure the summarization on R3 for 13 dot network with the subnet mask as /22. Then and only then it will be perfect.
There is another way, right? On R2, we can write IP prefix list CCI deny, and then 13/22, and then just mention less than, right? Less than 22 command.
Less than
22
on R2.
Yeah, or less than 24. So it will block.
So what will be the difference if I give over here less than 32? This less than 32 is for permitting all the networks.
Okay. Yeah.
Where you are telling the less than 32 over here in the deny statement.
Got it.
So but there is no slash value over here as 22. The slash value for 13 dot network is /24.
Okay.
Getting me? Understanding or not?
Yes, I got you.
Okay. So what we need to do, we need to advertise the summary route first on this interface on R3. So first I'll remove whatever I have configured over here, the distribution list. Okay, I'll go over here again on R3 and I'll say interface serial 3/1. Okay, on this interface I need to send the summary address. Okay, so the summary address, how I can do IP summary address rip 13.network/22 will be this. Okay, now I am advertising the summary address over to reach the R2's network. Now if you see over here, see I am getting summary route/22 for the first 4 loopbacks 0, 1, 2, 3, 4. I'm getting summary routes, correct? 0, 1, 2, 3. I'm getting summary routes /22 over here. Okay. Now I can configure the distribute list, whatever I've configured previously. See, there is no summary route. There is no summary route present.
Yes.
Only I can get 4, 5, and 6. The summary routes has been removed because we have denied the network to enter the routing table of R2. Getting me?
Yeah.
Okay. Got it now? So this is something prefix list using distribution list. Okay, these are something prefix list. Okay, now we can have one more thing known as route maps. Route maps. Route maps are similar to a scripting language, you can say. They are similar to a scripting language. Now, route maps are, as I told you, they are similar to a scripting language. They work like a more sophisticated access list. They work like a more sophisticated access list. Okay, they offer top-down processing. Once there is a match, leave the route map. Lines are sequence numbered for easier editing. Insertion of lines, deletion of lines. Insertion of lines, deletion of lines is possible. Route maps are named rather than numbered for easier documentation. Match criteria and set criteria can be used similar to the if then logic in a scripting language. So if else logic is there in the scripting language. So the same logic can be there over here also. Okay, with the route maps. Now the common uses of route maps are as follows. These Redistribution route filtering, a more sophisticated alternative to distribute list. Okay, if you are redistributing anything or if you are doing policy based routing, the ability to determine routing policy based on criteria other than destination network. BGP policy implementation, the primary tool for defining BGP routing policy. Okay, so route maps will see the source address, the destination address, the port protocol, and port numbers. Uses access list or prefix list to match the address. Okay, so route maps commonly used for they are commonly used for, you can say, policy based routing, as I've told you, route filtering. Now we have some task over here to configure on route filtering. Okay, policy based, we can check the first thing, that is policy based routing. Okay, policy based routing is something like, if I am having some policies configured, okay, like if I want to use some of the networks, should policy based routing means it will allow some of the network, it is used for implementing policies that cause the packet to take different directions. Okay, allows you to define policy which tells how the traffic is forwarded. Okay, if matches, forward based on policy, if not match, forward based on normal routing. Like suppose if you are having some network over here, okay, some users are there over here, and there is a router over here, and there are two connections on of the for the routers, okay, to go outside anywhere. There are two connections on the router. I want that when someone is going, if there is a 10 dot network from here, 10 dot network over here, or you can say 10.1.1.0/24 network is there over here. So I can do some policies that if someone is coming from any 10 dot network and he want to reach the some destination, then he will use this path. Okay, he will use this path, and for some other network it will use, they will use this path. So I can configure some policies on based on source, based on destination. Okay, so we will see practically how to configure the things. Policy based routing, PBR. This is the diagram. So just go through the diagram first. This is my client, suppose, and I am having a 40 dot network. This router is working as a client, and I am having 40 dot network on the client. These are my loopbacks on the client. This is something my ISP's router or something, and two links are connected to the ISP's router from my end router. Okay, and here I'm using 10 dot network, and the first link is using 1 dot network/8. It is using 2 dot network. Second link is using 2 dot network. Okay, Understood? So this is the topology. R1, okay, we are having the R1 over here. R1, R2, and R4. So IP interface brief. Okay, these are the IP addresses. Now loopbacks are not configured. I'll configure the loopbacks quickly. Interface loopback 0, IP address 14.0.0.1, 255, 255, 255.0. Interface loopback 1, 1.1, 2, 2.1, 3, 3.1. Okay, I'm having the loopback addresses configured. Show IP protocol. See what I'm running? I'm running EIGRP between the routers. I'm running EIGRP between the routers. Okay.
So just one question. How do you see the IP on interface with subnet mask?
Show run.
Oh, okay. There is no shortcut, right?
Show run will give me the.
Okay. Go.
Sorry,
Okay, go ahead. Sorry.
I cannot hear you.
I said okay. Go ahead. I got it.
Okay. So I'm running EIGRP over here. Show IP protocol. If I show you. Okay, I'm running EIGRP. I've advertised my 1 dot network, 2 dot network over here, whatever I've advertised over here. Okay. On R1, I'm running. Sorry, what I've done, I've made a mistake. There should be no loopback on R1. Loopbacks are there on R3. No loopback addresses are there over here. On R3, I have R3 is my client. R3 is having the loopback. Show IP interface brief. R3 is having the loopback. Show IP protocol. EIGRP over here. I have advertised my
Loopback
10 dot
IPs
network.
wrong, right?
Sorry.
Loopback IPs are wrong on R3. It should be 12, right? On R3.
What is wrong?
Sorry, my mistake. R2 is okay.
What is wrong?
No, okay, my mistake. Sorry.
Okay. On R2, show IP protocol, I'm running EIGRP. I've advertised my 1 dot network, my 2 dot network, both the links, my 12 dot loopbacks. Loopbacks are some servers that are there. Okay. Then we have 20 dot network in my LAN. Okay. So this is the thing, this is the default thing, okay, that we have done. We have configured all these things as per our diagram. Now, if I check on R1, if I check show IP route Eigrp, I am getting the 12 dot networks over here. We are reaching the 12 dot networks over here. Just a second. Okay, the bandwidth is 1000 over here. That is the reason it is not showing me the second. See, the bandwidth over here is been changed. The bandwidth value has been changed. Okay, that is the reason the second 3/1 is not showing over here. To reach the 12 dot network, I should get the two paths. Okay, so what I'll do, show IP interface, show interface.
Ideally Eigrp load balance, right?
Yes, that's what I'm telling you. I should get two paths over here. So here, see, serial 3/0, which is my first interface, it is having the default value, and on serial, if I check on serial 3/1, I've changed the bandwidth has been changed over here, 1000 kbps. So what I'll do, I'll make it again the default value. Interface serial 3/1. Bandwidth is 1544. Okay, the default value 1544 kb per second. Now if I see show IP route Eigrp, I will get two routes. I am getting two routes over here. I am getting two routes over here to reach the where? To reach my 12 dot network loopback.
So how Eigrp balance the load? Like first packet from the link serial 31, the second packet via 30. Is it like that?
One packet, one packet.
Okay.
One packet. It will send one packet from each part. Okay. So see, you can see now what I've done. I've changed the bandwidth, then I can see both the paths for every 12 dot network. I can see over here. Just let me go over here, show interface serial 3/1. Here also I'll change the bandwidth. Bandwidth, sorry, interface serial 3/1. The bandwidth here will be 1544 kbps. Okay, so I've changed the bandwidth over there also. Now you can see we are having the both the routes are there, both the routes are present over here. Now what I'll do, I'll again change the bandwidth. If I trace route now, trace route 12.0.0.1 from R1. See, one packet is going by 2.2.2, one packet is going by 1.1.2, then another 2.2.2.2. Okay. Now what I need to do, I need to just use one link. So what I can do, I need only one link. So what I can do, I can change the bandwidth. I can change the bandwidth of any of the link. So I'll change the bandwidth of the first, or I will change the bandwidth of the second 3/1. So whatever we have done, I'll change the bandwidth as 1000. Over here also, I'll change the bandwidth as 1000. Okay, now you will see only one link that will be there. Show IP route Eigrp. It is going via 1.1.1.2. If I trace route, see it is going via 1.1.1.2. All the packets are sent via 1.1.1.2. Okay, now policy based routing. Now I have some task over here written. I'll configure PBR on R1 as per the conditions. Now the traffic that is sourced from 14.0.0.0/24 and 1.0. I want these two networks should be forwarded via serial 3/0. That is my first link. If anything is coming to R1, it has to be sent. If anything is coming to R1, and if these two networks are coming to R1, then they should be sent via serial 3/0. Okay, this is my first thing. Traffic sourced from 14.2. And 3. Should be forwarded on 3/1. Okay, traffic source from 2. And 3. Network should be forwarded on serial 3/1. Okay, the other two interface, and all the remaining traffic means if something is coming from 40. Network, it should use the default path. What is the default path? 1.1.1.2. Understood? This is my plan. So how to configure the PBR now? First, we need to create access list. Why we need to create access list? Access list is for matching the network. We can create prefix list also. So I'll create access list 14.0.0.0. Okay, sorry, permit 14.0.0.0, 0.0.0.255, 1.0, 2.0, and 3.0.
While number 23 is random number or
Access list number, it is a random number, nothing like that. Okay. Understood. So I've created access list. Now I will create a route map. Route map. To create a route map, I have to say route map, then the word, what is the name of the route map? So CCNP, suppose the rate, the name of the route map. Okay. Then what we have deny or permit. Deny or permit. So what I will do, I'll say over here, sorry, I have done something wrong. Just give me a second. These two are my first rules. 0 and 1 are my first rule. 2 and 3 are my second rule. So I have to keep 2 and 3 in second access. 2 access list I want. I want 2 access lists. Okay. One is, so let me remove all the access list. Just a second. Okay, so see, I have two rules. So for both the rules are for different networks. So both the rules I need two access lists. Suppose first access list is 10 and I'll say permit 14.0.0.0 slash this one dot network. This is my first rule. This access list is for my first rule.
Okay.
Then second access list is suppose this for
you
my
can make 11, right? In access list 11. No, not an issue, right?
Sorry?
You can make the number as a 11, right? No problem, right?
Yeah, you can make it any number between 1 to 99. You can take any number. It is a numbered access list between 1 to 99. Standard access list. You can make it any number. This is for my second rule. Okay. Now create a route map. Route map CCNP. I'll say permit permit what? Permit a sequence number. I will give permit 10. Permit 10. This is a sequence number, just a sequence number.
That's it.
Okay. Then here I am having different options. Continue, default, description, exit, help, match. Match. I have to match something. I have to match what? Match IP address. Match IP address. From where? From the access list number 10. Match the IP address from the access list number 10. Okay, match the access list from match the IP address in access list number 10. Okay, so it will go and match the IP address. Then after matching, what you have to do, you have to set something. Set what? Set an interface for those IP address. Set interface serial 3/0. See, this is my rule. What is configured over here? I want that whatever these IP addresses are there, which whatever these IP addresses are there, these has to be matched. These are matched and set the interface as serial 3/1 for these IP addresses. Okay, so I've set the interface. This is my first route map. This is my first route map statement. Okay.
Yeah, it is 23. Match IP address 23.
See, match the IP address in access list 10. So those two IP addresses I have listed in access list 10.
It's 23,
remember,
right?
These two networks I have listed in the access list 10. So it will go and match those address. Okay, these are the address that are allowed. Others are denied in the access list. Then what it will do, whatever you have matched, set for that network, set the interface as serial 3/0. Understood?
Yeah, got it till here.
Sorry?
Yes, got till here.
Come again?
I got it.
Okay. Then we have second statement also. So I will just change the number. Route map CCNP permit 20. Now this for second access list, IP address 23. Set
Permit 23 number.
23 is for second rule.
And the 20 number is also random for what?
It is random. It is not something like that.
This is number for route map, right?
Access list. It is not for route map. It is a number for access list.
In access list, you have given only two numbers. That is 10 and 23.
Yes. So this 23 I am using in the second route map. Second route map statement.
So again 20 number I'm seeing there. That's why I asked.
This 20 is the sequence of the route map. See this, as we have access list sequence number, we have access list sequence number as for 10, 20, 30. This is the route map sequence number, how it will run. First the 10 will run, then 20 will run. It is random. You can take any number. Okay. This is the sequence number, how the sequence will be going. First, it will look for the first statement. If it matches, then it will come out. If it does not match, it will go to the second statement, that is 20. Okay. If second also does not match, it will go to the third statement.
I got it. Understood.
Okay. Then set interface for this serial 3/1. Okay. Now for what I have told that for these two you have to use these interfaces, and for all the remaining traffic it should be default path. So I have to give one more statement for one more route map statement. So see, if I give question mark, you can give any statement between 0 to 65,535, but it should be in sequence number 0, 1, 2, 3 like this. So I am using 10, 20, and suppose here it is 30. Understood?
Yeah.
Then here I will not give anything. Here I will not give anything. I will keep it as blank. If I keep any route map as blank, then it will come to know that the route map is permitting all the things. The route map is permitting all the other networks. Okay, understood?
All the other networks in load balanced way, right? Same way.
See, here we are having 10.40 network also over here. So what
Yeah.
I said for these two, you have to use the first interface. For the rest two, you have to use the second interface. And what about this? So I have to give something for this.
So this will be go via in a load balanced way, right? Like 30 and then 01.
No,
Sorry,
everything that is coming from here will go via this interface only. And everything coming from here will go via this interface only.
I'm saying about 40 network.
Sorry, 40.network. So 40.network, see, currently, if you go and see on R1, if I see show IP route, I am only using one interface. That is my 1.1.1.2. This is my default because I have changed the bandwidth of the second interface.
Yeah, understood. So it will go via the 1000, the higher interface rate.
Sorry, I cannot hear you properly, brother.
Now it's audible.
It is very low.
Still low.
Yeah, now it is perfect.
Okay, I got it. So 40 will go via the interface which having the higher bandwidth, which is 1000
Yes, the
kbps.
default link that it is using.
Okay.
Understood?
Yeah. Can we do trace something to test it's working or not?
Okay, so this is my blank, it was my blank route map. Okay, I have created a blank route map. Now I will implement that route map on the interface. So which interface I need to implement? On this interface, because every traffic is coming from here. So I'll go on this interface fast ethernet 0/0, and I'll say IP policy route map CCNP only. I've created the route map name, right? Yeah, CCNP. IP policy CCNP on this interface. Okay, then what I'll do, I'll just I'll start the debug IP policy. Okay, show route map. See, this is the route map that I've created.
Can you make screen this CLI bigger? Sorry.
Just a second.
Maximum.
See, this is the route map that what I've created.
Okay. So route map. Route map CCNP permit sequence 10. Sequence number is 10. Okay, got it.
Okay.
Yeah.
Now, if I go on my client, can I change?
Yeah.
if I go on my client and if I trace route, if I want to go to any of the network, whether it is 12.0.0.1, okay, and I will say the source is 14.0.0.1. See which interface it is using? 1.1.1.2. It is going via 1.1.1.2. Okay, if I go over here, you can see FIB policy match. FIB policy match, fast Ethernet, sending via serial 3/0.
This came up why? Because we are running debug, right?
Yes.
Okay.
Okay. Understood. Now, if I go on any other, that is my
0.20 as a source IP.
2.1. If I go on 2.1, it will go via 2.2.2.2. See, policy is match over here again. Serial 3/1. Policy is match. Serial 3/1. Understood?
Yeah. Understood. Can you show once the topology? I have to just write something.
Yeah,
IP
just a
address.
second.
Give me a minute, please.
Got it?
2 minute more.
Sorry?
Just hold more minutes, please.
Yeah, just a second. You want to see this topology?
Yeah. What is that? 10.1.1/8 or what?
Where
The R1F00?
it can be anything. It can be /8 or anything. You can do
No,
anything.
here in example we have considered what?
Yeah, we are having /8 only, I think so.
Okay.
Yeah, /8 only.
Okay, go ahead. You can take your screen now. The important
Understood?
thing is how to remember these all things. So that's why I'm noting it down on my notebook. Otherwise, for today it's look like good, and then after 1 week it's all blank. Okay.
Now, if I try to ping from 40.network, if I make the source as 40.network, if I trace route 12.0. Sorry, not from here, from the client, and if I take for 40.1.1.1, it will use the normal forwarding. See, policy matched, policy rejected, normal forwarding.
Why policy rejected? It
Because there is no policy configured over here. We have kept it blank. For all the other traffic, we have kept it blank.
okay. So match is coming because it comes under route map. The last one route map was what 20 or something.
Yes, there is a policy that is being created, but there is nothing inside it. So if there is nothing, normal forwarding is done.
Okay. Normal forwarding. I understood. Thank you.
Understood?
Yeah. Can you do show history command? Do show history on R1, so I will have those in one. Exactly. Okay. Okay, done.
Done?
Yeah.
Okay.
You can
So
stop.
we'll stop over here for today.
Yeah.